Ah, equation of motion. This one is the easiest to make your predictions with. Another way to represent the motion of an object is with an equation. We call equations relationships a lot. So if I ever say the word relationship, I'm just talking about an equation that relates multiple variables. We can write a position-time equation, formerly known as a position versus time equation, or position as a function of time equation. That might sound familiar to you. The equation can be used to tell us where the object is at any time we want. We can also write a velocity time equation, formerly known as a velocity versus time or velocity as a function of time equation. The equation can be used to tell us how fast the object is moving at any given moment. For now, we will only worry about position time equations. We're going to get more into the velocity equations and acceleration equations a little bit later on in the year. We learned last lesson that the average velocity is given by the equation, the displacement over the total time interval. If velocity stays constant, we can drop the AVG. So it's no longer the average because it's always going to be the same. We can rearrange that by multiplying by time on each side, and we see the displacement equals velocity multiplied by the change in time. Remember that your displacement is your final position minus your starting position. That little initial position down here, that 0, we pronounce that as naught, x naught. Likewise, delta t is our final time minus our initial time, or t naught. So expanded out, we have x, final position minus initial position equals velocity, multiplied by final time minus our initial time. Solving for the final position, we get this equation, where x is the object's position. I just told you what those were. You can pause it and take notes or read it if you like, but you should know that. The equation sheet for the final position should appear on your equation sheet. Note that the initial position in this version is put first, and the velocity has a subscript x, which just is reminding you that we're working with the horizontal motion. If we are dealing with vertical motion, as we will later, then we could change that to y subscript. If the velocity is constant, the acceleration is then 0, so this last term disappears, and what you're left with is this very same equation, just in a different order.